Imagine a telescope, not on a mountain, but floating in space. This is Hubble, the Hubble Space Telescope. It launched in 1990. It orbits high above our Earth. This special place gives it a super clear view. Our atmosphere blurs light. It has clouds. Hubble is above all that. It sees the pure, crisp light from distant stars. It is humanity's gleaming eye on the vast universe. A magnificent machine designed purely for discovery. Our silent, watchful sentinel in the dark sky. Hubble is a type of telescope, a reflecting telescope. It uses a very large mirror. This mirror is 2.4 meters wide. That's about the height of a small elephant. Its job is to collect light, especially faint light, light that has traveled for eons, from distant stars, from mysterious nebulae, and from countless galaxies. So many galaxies, far beyond our ability to count. Hubble sends its pictures, and its precious data, back down to us here on Earth, for scientists to study, and for all of humanity to marvel at. It tirelessly circles our home planet. Even before the ultra-deep field, Hubble was a superstar. It showed us incredible sights, like the famous pillars of creation. These are vast clouds of gas and dust, where new stars are being born right now. Hubble helped us measure how fast the universe is expanding. It found supermassive black holes, lurking at the centers of most galaxies. It even showed us changing weather patterns on other planets right here in our own solar system. Each image told a fascinating new story, adding another piece to the grand cosmic puzzle. But Hubble's powerful gaze can reach much, much further. It can peer into the deepest, darkest parts of space. And here's a cosmic secret. Because light takes time to travel across space, looking very far away also means looking back in time, far back, to the very early days of our universe. This allows us to see the first galaxies, as they were just beginning to form. This is like a form of cosmic archaeology. We are digging deep into the past, one single photon of light at a time. What a journey. So, astronomers made a bold plan. They chose a tiny, seemingly empty spot, a dark patch of sky, located in the constellation Fornax, the Furnace. To telescopes on the ground it looked blank, like an unwritten page in a cosmic book, but Hubble was aimed there. It stared intently. For many, many long hours, spread out over several months, its mission to collect the faintest, most ancient light. This ambitious project was named the Hubble Ultra Deep Field, a truly daring and patient observation. The result of this long stare was simply astonishing. It was not a blank image at all. Instead, it was an image filled with shimmering light, thousands upon thousands of tiny, colorful specks, and almost every single one of those specks was an entire galaxy. Astronomers counted about 10,000 galaxies, all captured in that one minuscule spot of the sky, each of those distant galaxies, containing billions of its own stars. Our universe is truly unbelievably vast, far bigger, far more crowded than we ever dared to imagine. It made us all feel very humble. These were not your neighborhood galaxies. They were incredibly far away. Their light had embarked on a journey lasting for billions of years. So when we look at them, we are seeing them as they existed, billions of years in the past, during the universe's extreme youth. Many of these early galaxies appeared small. They were often irregular in shape, not yet the grand spirals we see today. They were like the cosmic seeds of the later, much larger, mature galaxies. It was like looking at a nursery full of cosmic toddlers, just beginning to grow. The Hubble Ultra Deep Field is so very important. Think of it like a deep drill core. But instead of drilling into Earth, it drills into the universe. It shows us galaxies at many different ages, at various stages of their long evolution, all captured together in one single, breathtaking photograph. This allows us to trace the history of the cosmos, how galaxies slowly assembled themselves over eons, from the dark ages following the Big Bang, right up to the universe we see around us today. It is a precious, invaluable window into our past. How is it possible, you ask, to see the past? The answer lies with light itself. Light travels incredibly fast. It is the ultimate speedster in the cosmos. Nothing we know travels faster. It zips along at 300,000 kilometers, every single second. Yet the universe is so staggeringly enormous that even this cosmic speed demon, light, needs time, a great deal of time in fact, to make its journey across vast cosmic distances. This finite speed of light is the key. It is what allows us to become accidental time travelers. Consider this. When we gaze up at our sun, we are not seeing it as it is right now, we see it as it was. 8 minutes in the past, that's the time it takes for its light to travel across space and reach our eyes on Earth. For the stars we see at night, it's years. For other galaxies, it's millions or even billions of years. So our telescopes are more than just magnifiers. They are, in a very real sense, time machines. They capture ancient fossil light, photons that started their incredible journey, long before our Earth even existed. The Hubble Ultra Deep Field Image, it is filled with light from galaxies. Galaxies that are more than 12 billion light-years away from us. This simply means their light has traveled, for over 12 billion years, through the cold emptiness of space, to finally reach Hubble's waiting mirror. Now, remember, the universe itself is estimated to be about 13.8 billion years old, so when we look at these UDF galaxies, we are seeing them as they were, when the universe was just a tiny baby, less than a billion years old. Just try to imagine that for a moment. What did the universe look like back then? The ultra-deep field gives us clues. It was a very, very different place. The galaxies it reveals were generally smaller. They were much clumpier, messier. Often they were in the process of colliding and merging with each other. Star formation was happening at a furious pace, lighting up these young developing structures. It was a chaotic, incredibly dynamic era in cosmic history. The universe was still busy getting itself organized, building up the grand, majestic structures that we observe closer to us in space and time today. This view is truly precious. To achieve such a deep look into space and time, Hubble needed truly amazing technology. Hubble itself is a masterpiece of engineering. Its crucial instruments were even upgraded by brave astronauts on servicing missions. One key instrument was the Advanced Camera for Surveys (ACS). It has a very wide field of view and incredible sensitivity to faint light. It was the perfect tool for this deep cosmic stare. Another was the Near-Infrared Camera and Multi-Object Spectrometer (NICMOS). It can see even older, redder light from the most distant ancient objects. These tools are powerful. Behind the magnificent Hubble telescope, there is a large, dedicated team of people. They work at the Space Telescope Science Institute, or STSCI for short. It is located in Baltimore, Maryland, in the USA. These are the scientists and engineers who operate Hubble on a daily basis. They carefully schedule all of its observations. Scientists at STSCI meticulously plan the ultra-deep field. They process the enormous flood of data, making it beautiful and understandable, and available to the entire world. Their tireless work is absolutely vital. They are some of the unsung heroes of modern astronomy, creating the Hubble Ultra Deep Field Image. It was a monumental undertaking. It required hundreds of Hubble's orbits around Earth. That means many, many days of precious observation time, all of it focused intently on that one tiny pre-selected patch of sky. The data collected is made public, so that scientists all over the globe can study it and make their own discoveries. This open approach fosters wonderful collaboration, and it greatly accelerates scientific progress. It's a shining testament to human curiosity and our innate, unyielding desire to explore the unknown. The impact of this single image has been profound. The Hubble Ultra Deep Field literally transformed astronomy. It provided us with the clearest, deepest view ever of the early universe's young galaxy populations. It helps us to understand how galaxies first formed, and how they have changed and evolved over cosmic time. It shows us our own cosmic roots. Where did structures like our home galaxy, the Milky Way, come from? The UDF offers vital clues to these big questions. It fills us with a deep sense of awe and wonder about our place in this vast ancient cosmos.